Hello everyone, and welcome to this example recording on power and energy. So in this example, we're going to be determining the powers P1, P2, V1, and I2. The power P1 is the power associated with this resistor. The power P2 is the power associated with the dependent voltage source. The voltage V1 is the voltage over this resistor, and the current I2 is the current that flows into the reference terminal at this point. Right, so what we need to know, quite important, we'll remember that power is equals to voltage multiplied by current, which is the same as current squared times resistance, which can also be written as voltage squared over resistance. Over and above this, we must remember that when dealing with power, power can either be positive or negative in magnitude and polarity rather. And how we differentiate is that we say if current flows in a voltage rise direction for any element, be it a resistor or a source, the power will be smaller than 0, whilst if current flows in a voltage drop direction, then the power will be greater than 0. So current flows in a voltage rise direction, the power will be smaller than 0, in other words, negative. And if power is flowing in a voltage drop direction, positive to negative, the power will be positive in sign. Right, so now let's apply this. I think a final thing to keep in mind is that when dealing with these equations, you know that equation 1, we'll call this 1, will be applicable for all your elements, whilst equation 2 and equation 3 can only be applicable for resistive elements. So in other words, you cannot use equation 2 and 3 to get the power P2 because we don't know the resistance of the dependent source. Alright, so we should have enough knowledge to then go ahead. So let's take a look. The first one was to determine the power P1. So we've got a resistor there. So the power P1 we can say is equals to I squared multiplied by R. We've got the current there as 6, so it'll be 6 squared multiplied by the resistance, which is 5, and this should be giving us a final value of 180 watts, and that's the wattage in magnitude. Now, what will we define as the direction of this? So passive sign convention will dictate that the voltage drops in that direction, and if the voltage is dropping in that direction, then current is flowing in a voltage drop direction, implying that the power is greater than 0, which is typically what we would expect with a resistive element. It absorbs power, so the power should be greater than 0. And so that's the first calculation, P1. What about P2? P2, we know we can't use equation 2 and 3, so we have to use equation 1. So P2 must equal to V multiplied by the current. So take a look at that. We've got the voltage, V equals to 10 I1. The value for I1 is 6 amps, so it's going to be 10 times 6, which then gives me 60 volts. What about the current? So if we take a look at the circuit, we would need to find a way to get the current that's flowing in this direction and up into the circuit. How are we going to do this? We can do a KCL at that point. We know that 6 amps is going up. We know that 10 amps is going in. So 10 goes in and what goes out is 6, and that means that this must be 4 amps. So the current is actually flowing in the opposite direction, and it is 4 amps. Alright, so we can say the current is equals to 4 amps. P2 is going to give you VI, which then gives you 60 times 4, and that should give you 240 watts. and that's magnitude. What about sign? Current is flowing in a voltage drop direction, so that tells us this power must be greater than 0. So it's positive. All right. What about the rest? V1 and I2. So how are we going to find V1? Well, we can take a look at a KVL in that mesh. So if we do a KVL in mesh 1, we're going to say minus the voltage of the dependent source, which we calculated as 60 volts. Then the voltage here is negative 10 plus 20 minus V1 is equals to 0. And then I calculate the value of V1. So V1 is going to give me 60. So minus 60 minus 10 is minus 70. Plus 20 will be minus 50 volts. So minus V1 gives me positive 50 volts. So V1 will give you negative 50 volts. Right. And the final question requires us to determine I2. I2 is the current flowing at this point. How will we find this I2? Well, we know that the current flowing in here is the 4 amps. The current that was flowing here is going to be the same current. We're looking for I2. Can we find the current that's flowing in here? Well, we've got 10 amps going out and 2 amps going out. So something must be going up here, and that which is going up must be 12 amps. 12 amps becomes 10 plus 2. So 12 is going up here. So if we do a KCL at this point, we're going to say that I2 plus 4 is equals to 12. That tells us then that the current I2 must give you 8 amps. So I2 then gives you 8 amps. And that's how you determine the power and the voltage requirements of such a circuit. Thank you for watching this video and enjoy the course.